Greetings, everyone, and welcome to SpaceWeek Live for Sunday, November 29th, 2020. So we had a very eventful week last week. Let's get right into it. Last Monday, China launched their Long March 5 rocket with the Chang'e 5 lunar sample return mission. Let's first of all, let's check out the launch, and then I'll talk about the mission. Oh, hold on a sec. There we go. Need audio from the browser.
明白。10秒，9、8、7、6、5、4、3、2、1。 点火。
大家看到发射台的喷水，这样的话喷出来大量的水之后，其实对发射台是一个保护的作用，因为火箭的这个尾焰的温度非常高，如果不保护的话，这个发射台经过一次之后就需要大量的修复。
8到6毫秒。
这个火箭这个起飞过程非常非常的
对。
因为是在夜间发射，所以这个地面光学看的效果就。 跟上海法可能相比就不如上海法好，
跟踪正常，
但是非常耀眼。
但是非常耀眼，对，我们能看到这个发动机喷出来的这个尾。
Beautiful launch, very cool looking rocket. We don't get to see this sort of thing very often because China doesn't live stream most of their launches, but this was a big one for them. This is their lunar sample return mission, the first lunar sample return in 46 years since Luna 24 from Russia back in the 1970s. So the launch was a total success, and then Chang'e 5 entered lunar orbit yesterday after its 112-hour or 4.7-day journey. And interestingly, along the way, there were amateur radio enthusiasts that tracked the craft, and they even managed, They even managed to, I won't say intercept because they didn't like steal the data from China, but they managed to monitor and decode a video of one of Chang'e 5's solar panels glinting in the sun with bits of dust or ice floating around. So that's really cool. Just an amateur radio enthusiast I think he's in the UK, pulled these signals out of the sky, and they were able to decode the video. So let's check that out. That's pretty neat. There's not much to see, but it's still very neat. So it's just a few seconds. We see the solar panel edge on, and some little bits of dust and stuff flying around, or ice particles or whatever. The flashes you see, the little pixel flashes you see, are possibly radiation hitting the camera sensor. It's also possible that they may be little bits of dust, but they're brief enough that and their movement is different enough from the dust that we see floating around that I think that they are particles of radiation interacting with the camera sensor, which is normal whenever you see, like especially in low light, whenever you see time lapses or video from a spacecraft traversing a region that is, that has an increased level of radiation, you can always see the little pixel flashes of that. Let's see. So then at 249 miles or 400 kilometers distance from the moon, Chang'e 5 fired its main engine for 17 minutes, slowing it down so the moon's gravity could capture it. Chang'e 5 has 4 main parts that are currently, I believe at this time, until it begins its descent mission, still connected together. The orbiter, which is circling the moon, the re-entry capsule that will return to Earth, the lander that will land on the moon, and the ascent vehicle that will take off from the moon. So they're connected in that order. And, so the re-entry capsule is sandwiched in between the orbiter and the lander. And then soon, possibly today, the lander and the ascent module will detach from the orbiter and the re-entry capsule. So the orbiter and the re-entry capsule will remain connected, and the ascent module will remain attached to the lander, but they will disconnect. The lander will land on the lunar surface near Mons Rumker, a volcanic formation near the northwestern limb of the moon as seen from the Earth. The landing site was chosen for a few reasons. First, Mons Rumker is thought to contain comparatively young rocks at just 1 billion years old. All of the moon rocks collected by the U.S. Apollo and the Soviet Luna missions were more than 3 billion years old. Second, Mons Rumker is visible from Earth. In order for the spacecraft to communicate directly with Earth, it needs to land on the Earth-facing side of the moon, rather than on the far side where the Chang'e 4 rover landed last year. I think it was last year. To communicate with, so going back to Chang'e 4, to communicate with Chang'e 4, China had to pre-position a relay satellite in a halo orbit around, here, this is actually a picture, a photograph of Mons Rumker taken from Apollo 15. That's pretty cool. So in order to communicate with Chang'e 4, the previous moon rover that's on the far side of the moon, China had to pre-position a relay satellite in a halo orbit around the Earth-Moon L2 Lagrange point on the far side of the moon. So if you're not familiar, Lagrange points gravitational interactions are complicated, and one of the cool effects of two-body orbital mechanics is that there are these special locations called Lagrange points on the in between the two objects, and then on the far side of the orbiting object, and then on the opposite side of the object that's being orbited, and also 60 degrees ahead of and behind on the orbiting object's orbit. So these are gravitationally stable or semi-stable points that, due to just the coolness of gravitational interactions, you can actually orbit a satellite around an imaginary point in space that is gravitationally stable with relation to two bodies. And so China orbited the the Chichao satellite on the far side of the moon in a halo orbit. It entered that orbit 2 years ago, and it has 3 more years left in its originally planned 5-year lifetime. I don't know if it will be able to extend beyond that, or if it has fuel requirements that will cause it to become end of life. But so for future missions, that satellite on the far side of the moon remains in orbit for China to use if they so desire. Thirdly, China wants to maximize their lunar daytime. Chang'e 5 does not have an onboard radioisotope thermoelectric generator, or RTG, to keep it warm like Chang'e 4 did. So it's unable to survive the extended cold of lunar night. Remember that although Earth rotates every 24 hours, the moon only rotates once every 29.5 days. If you're standing on the moon, you'll have about 2 weeks of burning daylight, followed by 2 weeks of freezing darkness. The sun is just now, as we speak, rising over Manzurumker, beginning a lunar day. The full moon happens early tomorrow, November 30th at 4:30 a.m. Eastern, 9:30 GMT. The first full moon in November is called a beaver moon, by the way. I hate those names. Wolf, snow, worm, beaver. It's just the moon. Just like people call lunar eclipse a blood moon. There's nothing bloody about it. It's just and as a matter of fact, people attribute it to blood, but it's just the moon in Earth's shadow being illuminated by all the sunsets in the world being refracted onto the surface of the moon at the same time, which is kind of mind-blowing when you think about it. But anyway, back to the mission. The Chang'e 5 lander is equipped with a 2-meter drill and a scoop. It will collect about 4.4 pounds, 2 kilograms of lunar rocks and dust, and place it in a container on the ascent vehicle, or the ascent vehicle. The ascent vehicle will then blast off the surface of the moon and rendezvous with the orbiter and the entry capsule, the re-entry capsule. The sample container will be once that rendezvous is done, the sample container will be transferred from the ascent vehicle to the re-entry capsule. Because the ascent vehicle is not equipped to deal with the rigors of re-entering the Earth's atmosphere, the re-entry capsule obviously is. Then the ascent vehicle will be jettisoned. The orbiter will fire its main thruster to leave lunar orbit and start its 4.5-day trip back to the Earth. It will release the re-entry capsule before arriving. The orbiter will burn up on re-entry, and then the re-entry capsule will parachute down to a safe landing in Inner Mongolia, a large autonomous region in northern China, around December 15th to 17th. Not expecting any coverage of that, but we'll hear. I mean, not any live coverage, but we'll certainly hear about it, whether or not it's successful. So moving on. On Tuesday, there was another Starlink launch after it was delayed once or twice. Let's check that out real quick. This brings the total number of Starlink satellites to 904.
T-minus 15 seconds.
Falcon 9 is configured for flight.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Vehicles pitching downrange.
M1D.
Another successful Starlink mission. On all counts, the booster performed admirably. Starlinks were deployed just fine. And where's that pesky drone ship landing? Maybe around here somewhere. Oh yeah, here we go.
Stage 1, landing leg deploy.
Landing legs have deployed. Here it comes. All right.
Landing confirmed.
And for the 7th time, this Falcon has landed.
Indeed, this was the first time that SpaceX has launched a Falcon 9 booster for the 7th time. So this is the new fleet leader, as they call it. And here is the release of the Starlink sats.
Looks like we have a visual there.
Starlink deploy confirmed.
And call out of confirmation of Starlink deployment. So those 60 Starlink satellites gently floating away from the second stage. And because of the spin on the second stage, they'll start to space themselves out. Soon, they'll deploy a solar array that they have on board, and then over the next few days and weeks, they'll distance themselves out further using an onboard ion thruster to make their way to an operational orbit about 550 kilometers above the Earth's surface.
Thank you, intrepid SpaceX commentator. So, yeah. And then on Saturday, a Russian Angara A5 rocket was supposed to have its second test flight, but that was delayed until at least December 11th, which is not this week. So the Angara has been in development for a while. They had a few years of delay. I think the first test flight was like 6 years ago in 2014, and then the second test flight has been delayed for quite a while. Then on Sunday, Japan successfully launched their first JDRS satellite, that's the Japan Data Relay System satellite, into geosynchronous orbit. JDRS is an optical communications satellite that uses lasers to ferry information between other satellites in low Earth orbit, because it's sitting 22,000 miles away in geosynchronous orbit, and ground stations. Now, there was no official JAXA coverage of this event, but Nico Video Visual Solutions was kind enough to provide on the scene live views of the launch, which we can check out here. It would be helpful if you could see it. There we go. Look at that. Look at that pitch maneuver. My goodness. When I saw that, I got worried because that was an intense turn that the rocket did. But apparently that is normal for the H-2A rocket, and the launch appeared to be successful. But little hair raising, but yeah, there we go. So, yes. Now, moving on to this week, we've got. Yes. Okay. Moving on to this week. Today, Sunday, November, and I'm sorry, that H2A launch, that was early this morning. That was actually at 2:15 this morning, my time. So that was very recent news. But later today, at November 29th, at 8:33 p.m. Eastern, 1:33 a.m. GMT, an Arianespace Soyuz will launch the Falcon Eye 2, hopefully successfully launch the Falcon Eye 2 spacecraft, satellite. Now, Falcon Eye 1 was supposed to have launched last year, and, well, it did launch last year, but the launch was a failure. It launched on a Vega rocket, also from Arianespace, and as the second stage, at second stage ignition, something went wrong, and the rocket started losing, its trajectory degraded, and it fell into the ocean. And that constituted the largest to date satellite insurance claim on record, which was $411 million equivalent. Now, and that was a satellite for the UAE. It's a spy sat for the UAE. Now, why the United Arab Emirates needs to spy on the rest of the world, I have no idea. But they're rich and they bought a satellite, so there you go. Now, Arianespace had a second mishap. They did have a successful Vega launch earlier this year, but they had a second Vega mishap just last week, when two satellites for Spain and France were on board, and because Vega is a 4-stage rocket, and it got all the way to the 4th stage and everything was looking fine, but then the 4th stage AVUM engine did not thrust in the right direction. It threw off the rocket's trajectory, and even though it was already up in space by that time, its trajectory degraded and the payloads were lost. I'm not sure where they came down, but it was way downrange, like thousands of miles. And those totaled about $370 million, which, and including, so they were, let's see if I can recall the names. The second satellite was Taranis, which I don't remember what the word means, but it was actually going to be a very cool satellite. It was going to study it was going to study transient effects, the sprites and red whatever that shoot up into the atmosphere from the tops of storms. You may have seen pictures or video of a phenomenon like that. It's really fascinating, and it has not been studied very well, and they're tough to catch. And so this satellite was going to study them, but now it is lost. Hopefully they can resurrect it and rebuild the thing. Then on Wednesday, December 2nd, sometime between 9 a.m. and 6 p.m. Eastern, that's 2 to 11 p.m. GMT, SpaceX Starship SN8 might be flying to a height of 15 kilometers. So we say might because Starship is still in development, and the test times are very fluid. Although Elon Musk did confirm that, so they were scheduled for tomorrow, but the weather wasn't looking so good. So they're going to do, not only was the weather not looking good, but they also felt the need to do another static fire of SN8, which has already done, I think, 3 static fires. one of which was not entirely successful. It like the last one was successful, but the one prior to that burst a like a pressure disc. I forget the exact name of the part, but it burst a pressure disc that is designed to relieve pressure so that the rocket doesn't rupture, so that the tank doesn't rupture. But the previous static fire was successful, and apparently they're doing one more tomorrow, followed by possibly a 15-kilometer flight on Wednesday. Now, there are a couple of ways. Well, there are basically 3 ways we know that a test flight is coming, a hop or whatever. Now, this is more than a hop. This is a 15-kilometer flight, but there's a few ways that we know that one is coming. Firstly, we have the notices to airmen that are published by the Federal Aviation Administration that identify temporary flight restrictions, or TFRs, for a given area. Now, this what you're looking at is the TFR for the SpaceX site in Boca Chica, Texas. But it extends all the way from October 31st to December 31st. So it's basically just a blanket TFR that covers, the SpaceX, the airspace around the SpaceX site for the months of November and December. And secondly, are the Cameron County, Texas road closure notifications. So in order to launch, they have to have official road closures authorized by the county. And we see here on December 2nd, which is going to be Wednesday, is their final secondary date currently listed on the Cameron County road closures site from 8 a.m. to 5 p.m. Central Time. That's 9 a.m. to 6 p.m. Eastern Time. And thirdly, we have tweets from Elon Musk, who says that there may be a flight on Wednesday. And fourthly, sites like Lab Padre, which I will now link in the chat, have their eye on the site 24/7. So, if SpaceX is leading up to a test, a static fire, or a launch, they can see, because they can see the activity at the launch pad. Then on Thursday, December 3rd, at a time to be determined, a Russian Soyuz 2.1B will launch from far northern Plesetsk Cosmodrome with a Gonets-M communications satellite and a cluster of international rideshare smallsats heading for low Earth orbit. This launch was delayed from last Tuesday, and there won't be any live coverage because this is a Russian government launch. Then on Saturday, December 5th at 11:39 a.m. Eastern, 4:39 p.m. GMT, a Falcon 9 will launch CRS-21, the first Dragon 2 cargo spacecraft to the ISS. I'll be doing a live Q&A starting about an hour before the launch, so starting at 10:39 a.m. Eastern, or 10:30 a.m. Eastern. I'll round it. Previous SpaceX cargo missions used the Dragon 1, which had no autonomous docking capability. Dragon 1 had to be captured and attached to the space station using Canadarm2, the space station remote manipulator system, or robotic arm. Dragon 2 Cargo and Crew Dragon are variants of the same design. So Crew Dragon is the crewed version of the Dragon 2, basically. What I'm not sure about is, and I should look this up because I should know it, is I presume that the Dragon 2 cargo craft also has Super Draco thrusters. The question is what they're used for, because on the Crew Dragon, the Super Dracos are used for launch escape. If the crew has to abort the mission during launch, the Super Dracos will fire and carry them off to safety. But I'm not sure if they exist on the Dragon 2 cargo variant what their purpose is, because you don't need to escape cargo. Maybe they would. I don't know. to save the cargo. But in any case, the difference between Dragon 1 and Dragon 2, Dragon 2 is able to dock themselves to the space station with no human interaction, as we already saw with the Crew Dragon on the Demo 1, Demo 2, and Crew 1 missions. Then 22 hours later, on Sunday, December 6th, starting at 9:30 a.m. Eastern, 2:30 p.m. GMT, is coverage of the rendezvous of CRS-21 at the space station, with the docking happening about 2 hours later. Now, I have been talking a lot, but let's take your questions. If you haven't already been asking questions, please feel free to do so. Please tag my name, Rawspace, so that we notice it amidst all the other chat. And let's see what we got. All right. Canon Luke. Now, this is going back to what we were saying earlier about eclipses. Canon Lucas, any news on the 14 December total solar eclipse here in South America? Interesting. Let's check it out. Now, as I've discussed before, I have no problem looking things up, because after all, that's how we learn. Time and date, perfect. They're the experts. December 14th, total solar eclipse. Now, didn't they just... What? Really? They just... Chile and Argentina, they already had a solar eclipse, like last year. Or earlier this year, I forget. But they just had a solar eclipse, and they get another one. They're so spoiled down there, I swear. But you can see the path of the eclipse across Chile and Argentina. Pretty far south, but yeah. So that will be on December 14th, and when is totality? Well, it's in 14 days, 17 hours, 1 minute and 25 seconds. Okay, so December 14th at 13:33 UTC. That's the same as GMT. So that's 13:33, 1:33 p.m. GMT. Whatever your GMT offset is, you can calculate from there. But interesting question. All right. Canon Lucas, any news on Hayabusa 2 return samples of Ryugu? That is returning. Busa 2 return. Let me get that date. Round trip return, Hayabusa 2, Earth arrival. Wow. R minus 5 days. Re-entry, I guess, is R. So, Hayabusa 2 will be arriving. They don't have a time listed. I don't know. Now, Japan might possibly live stream that event. But 5 days from now would be, what, Thursday? So Hayabusa 2 apparently will be returning on Thursday. I will go ahead and link my schedule in the chat. That's the Rawspace calendar. Feel free to refer to that to keep up to date on launches and upcoming events. Avir Tour. Who is doing the launch? SpaceX or... I'm not sure which launch that's referring to. I don't have the context for that one. Canon Lucas, I hope the James Webb isn't launched on an Ariane Space Vega rocket. No, James Webb is way too big for Vega. That's why, yeah, it will be launching on an Arianespace Ariane 5 rocket. Yeah, because of the fairing capacity, the payload fairing is big, and it has a vertical integration capability, so they are able to stack the payload, stack the James Webb, the precious James Webb, on top of the rocket in a vertical orientation rather than while it's laid out on the ground. And yeah, cross your fingers. I'm sure they will redundantly check the bejesus out of that thing before they launch it, because if they screw that up, I would say Arianespace is kind of toast, but that's only because they would be losing a, what, 10, 15, $20 billion mission. I have no idea what it's cost so far. Some huge, ungodly amount. Ken and Lucas, very good information. Thanks for streaming. It's my pleasure. Slim Pickens, how many bowls of regular cereal does it take to equal just one bowl of total? I should know that, because I grew up in the era where those ads were shown on TV. Like 6? I don't know. Boyka wants to see Bennu. Sure, I can show you Bennu. Let me find a picture of Bennu. Where is my photo of Bennu? There he is. I'll just leave him up. Rather look at him than me. Stephen A., love your channel. Keep up the great work. Thank you very much. You're too kind. MVM Motovlog Music. Alexander says... Alexander says Dracos on Crew Dragon are used for deorbiting. I mean... yeah, I'm not sure. Maybe. I'll have to look that up. Alexander... differences between crewed and cargo dragon, the cheaper they are. Yeah, cargo dragon is definitely cheaper than crew dragon. I'm not sure what all the list of differences is, though. It'd be interesting to see that, tabularized list of what's different between the two models, variants. Football Ian, what do you think about relativity space? Like Einstein's theory of relativity? Relativistic time dilation? Not sure what your question is there. Okay, back to the main chat. Let's see. Okay. All right. So I would like to do one more thing, and that is to welcome our new members this week, both Rawthlings. We have, if I were a Twitch streamer, I would have some little fanfare with confetti and animated GIF or GIF, but alas, I don't. Anyway, welcome to the Rawthlings, Aaron Disario and Mike B, who joined just yesterday. Glad to have you both aboard. They have access to cool emojis like Bennu, Dab, and Elon the Toker, as well as other perks which you can see on the members page if you take a look. All right. Talking about Chinese astronauts or taikonauts, Snow Kitten says they will build a space station and are planned to launch people next year. They're expecting a manned lunar launch only somewhere early next decade, as far as I know. All right. Football Ian says that Relativity Space is a space company that's working to launch a 3D printed rocket from Cape Canaveral and Vandenberg. Okay, so it's a company, we're not talking about a scientific concept or a hypothesis, a theory. So I don't know much about relativity space in that case, but it sounds like an interesting topic to delve deeper into sometime. All right, so that will do it for this week. Thank you all so much for coming, those of you who are still with me, and look forward to a successful Arianespace Soyuz launch tonight. Now, I should mention Arianespace Soyuz. If you're not already familiar, if that's confusing to you because you're like, Soyuz is Russian, what's Arianespace doing? Arianespace purchases Soyuz rockets for their medium lift capability from Russia. So Russia manufactures them, sells them to Arianespace. Just like, Italy is a member of the European Space Agency. Vegas are actually Italian-built with Ukrainian-made engines, I guess. But so that's why Arianespace launches Soyuz rockets. They fulfill their medium launch capability. The small launches are handled by Vega, medium by Soyuz, and the heavy lift is handled by the Ariane 5, which is soon to be replaced by Ariane 6. All right, so thank you all for coming. Keep it raw, and may the Bennu be with you. I don't know if that works, but thanks once again. Take care. Catch you next time.